Hello there, Mr. Sutton here, bringing you the Algebra 2 3-3 Part 1 homework solutions on solving by square rooting and completing the square. On this problem, they want us to solve this using square roots. Since we already have this squared term completely isolated, we just need to take the square root of both sides. So square rooting the left side just gives me the x plus 4 that's inside the squared parentheses. On the right side, we need the square root of 16, which is 4, and we have to remember to include the positive and negative root of that since we're square rooting an equation. To get x by itself, I just have to subtract 4 over to the other side. And then I have negative 4 minus 4, which is negative 8, and negative 4 plus 4, giving me 0. To solve this problem using square roots, I already have the squared term by itself, so I can just square root things right away. On the left side, that's going to give me x minus 7, and square rooting the right side, this would normally be 3, but since it's a negative 9 that we're square rooting, we actually get 3i because we have to take an I out of that. And we also can't forget the plus or minus. So plus or minus 3i is everything I have over there. Then I just have to add the 7 to get the x by itself. So we end up with 7 plus or minus 3i, which I can't simplify any further. To solve this problem using square roots, we're going to want to actually factor the left side here, which happens to be a perfect square trinomial. So we just have to take the square root of the first and last term and stick those in that squared parentheses with the sign of the middle term. So square root of x squared is x. Square root of 16 is 4. The negative here means we're using a negative 4. So x minus 4 squared equals 25. And just to double check, if I multiply these two things together and double it, 2 times negative 4 is going to give me that negative 8, so that actually does work. Now that I have a squared parentheses on the left, I can square root both sides. So that gives me x minus 4, and don't forget the plus or minus because we're square rooting an equation, so plus or minus 5 over on the right side, the square root of 25. Then let me just add 4 over to the other side to isolate x. So 4 plus or minus 5. I can combine these, so let me simplify this a little bit further. 4 minus 5 is giving me negative 1, and then 4 plus 5 gives me my other answer of 9. To solve this equation using square roots, let me first factor this left side, which is a perfect square trinomial, into a squared binomial. So basically, square root the first and last thing and stick it in a squared parentheses. So square root of x squared is going to be x. Square root of 81 is 9. I'm going to use the sign of this middle term here, so minus 9. Quantity squared equals 5. And just to double check, 2 times x times negative 9, 2ab in other words, does give me negative 18x. So this is the true factorization. Now if I square root both sides, I can get x by itself. Initially I get x minus 9 on the left side, and plus or minus the square root of 5 on the other side. Can't forget the positive negative. And then let me just add 9 over to the right to get x by itself. So 9 plus or minus radical 5. For the next few problems, we're being asked to complete the square for an expression and then factor the trinomial. So for all of these, we have to take half of the b value, that's the coefficient of x, and then square that and add it in there. So half of 10 for my b here is going to give me 5, so 10 over 2 squared is really 5 squared. And then I just have to add that to the equation here, or the expression. So that's x squared plus 10x plus 25. Now to factor that, I'm just going to square root the first and the last thing and keep the sign of the middle. So we have x plus 5 whole thing squared. To complete the square for this expression, I'm going to take half of my b term and square it. So the b term is negative 5, so we have negative 5 over 2 quantity squared. And when I add that back in, I'll simplify it. So this is going to become 25 over 4 that I'm adding in there. And if I want to factor this, I just have to unsquare the z squared and unsquare this expression here and put it all in a squared parentheses. So that's going to be z minus 5 over 2 quantity squared. To complete the square for this expression, we need to take half the b value and square it. So our b value in this case is negative 22, So dividing that by 2, we get negative 11. That's what I'm going to be squaring and adding back over here. So this gives us a 121 that I'm throwing on the end of that. And now to factor it, I just square root the first and the last thing and stick it in a squared parentheses with the middle sign. So we have t, the square root of t squared, and 11 is the square root of 121. We'll also keep a negative with that, so minus 11 quantity squared. For this one, we're completing the square on this expression and then factoring it. To complete the square, I need half the b value squared. The b value in this case is this negative 6. So half of negative 6 is negative 3. That's what I'm squaring and adding over here. So I'm adding a 9 then. And if I want to factor that, I just need the square root of x squared and 9 and in a squared parentheses with a minus there because this middle term is negative. So we've got an x for the x squared, a 3 representing the 9, and the negative represents that middle term right there.